Miss King here, and in this screencast we're going to look at enzymes. We said that enzymes were one of the functions of protein molecules. They act as catalysts, which help speed up chemical reactions in living things. And we said that they work with our metabolism. Without enzymes, our metabolism wouldn't be fast enough to keep us alive. So enzymes are very important molecules that play a role in keeping us alive day to day with our chemical reactions. Activation energy is basically how enzymes work. This is the energy that we need to start a chemical reaction. Whenever we have enzymes present, we don't need as much of that energy, so it does help to speed the chemical reaction along. So what that looks like, let's think if we're doing a chemical reaction, we need a lot of energy to get that reaction started. So think about this guy pushing this rock over this hill. He's going to have to use a lot of energy, and it's going to go really slow before he gets over that hill where our chemical reaction can take place. If we put that on a graph, it would look something kind of like this. If we eat some food, let's say that our reactants are some food, and we need to do digestion, break them down into their smaller parts, we have to have all this energy in between this red line and this dotted line. So all of this is a massive amount of energy that we would need to get this chemical reaction started to break this down into its smaller parts for digestion. Now, if we add an enzyme to the picture, enzyme's going to help lower the amount of energy that we need. So now the guy pushing this big rock, he doesn't have to use nearly as much energy, and he's going to get over this hill a lot faster. So our enzyme is basically going to make it so that we need less of this energy to get our reaction going. So it's going to go a lot faster, and that'll give us the ability to digest our food within a reasonable amount of time to get the energy that we need from it. So there's some terms that we need to look at with enzymes as well. The first term is substrate. The substrate is basically the molecule that our enzyme is going to work with. Of course, we have our enzyme, and on our enzyme there's a specific location where our substrate will combine or attach, and that's called the active site. And then our product is what we're going to make at the end of our reaction. So our enzyme is going to give us a product. Alright, so enzymes are reusable. We can use them over and over again to do the same chemical reactions. They're also very specific. Each enzyme has an active site that will only fit with one type of substrate or one type of reactant. So if you look at the picture, you can see that this specific enzyme fits with the shape of my molecule. Okay, so we could take that and sit it right in that active site. This green enzyme, however, does not have the same shape as my molecule, so this is not going to work. This molecule cannot be worked with this enzyme. It just doesn't fit the active site. It has to fit specifically. You can kind of think of that like in the analogy of a lock and a key. The key has to fit the lock in order for it to open whatever it is you're trying to open. So if you're at your house and you stick your car key into your front door of your house, well, that's not going to open your door because that key doesn't fit the lock, kind of like this bottom picture. You have to have the correct substrate and the correct enzyme for it to work. Enzymes can also become denatured or change their shape when they're in harsh conditions. Each enzyme has a specific pH and temperature where it works best. What happens is things like your stomach has a very acidic environment, so the enzymes that work in your stomach like for it to stay acidic. You also have enzymes that work at specific temperatures. So, for example, if you get a fever, that causes your body temperature to rise, and if your body temperature rises, then that's going to cause the enzymes to denature. So we don't want to get a fever. Think about when you get a fever, if you drink milk, it's going to cause you to throw up. And we don't want to throw up. The reason why you throw up is because your temperature rises too hot, and that causes the enzyme called lactase, which breaks down the milk. It causes that enzyme to become denatured. So lactase won't work anymore. So if you drink milk while you have a fever, the enzyme doesn't work and you end up throwing up. Okay, and then of course we said that enzymes catalyze reactions by lowering the activation energy. And here's a good picture that shows the denaturation of an enzyme. Think about an egg. The protein in an egg we said was called albumin. It's a storage protein for the baby chicken. So when you crack the egg and you put it in the frying pan, it starts out in its normal state. This would be like a diagram of that structure. And then when you start to heat those proteins, that protein albumin, the heat causes it to change its shape until eventually it's out of shape so much that the protein doesn't work anymore, and that's where we have our completely cooked fried egg. Alright, and there are a few things that affect enzymes in our body. We already talked about temperature and pH. And then concentration as well. The more enzyme you have, the faster the chemical reactions can go. So we want to have plenty of enzymes to be able to do our bodily processes. So that's why, one good example is people who are lactose intolerant. They simply don't have enough of the lactase enzyme to break down the milk. So they can't really drink milk. It kind of makes them sick if they do. All right, and that is basically how enzymes work. And be sure to bring any questions that you may have about enzymes to class with you.